Hello, welcome everyone, and welcome today to our socialprotection.org and Development Pathways joint webinar. I'll just share my screen with you to start things off as everyone continues to join. Okay, so welcome everyone. The name of today's webinar is Are We Harnessing the Power of Machine Learning in Social Protection? I'll be your moderator for the session. My name is Laura Ulanowski and I run the communications and strategy at Development Pathways. It's with pleasure that I welcome you all and thank you very much for joining us today at the start of the new year. So what is today's webinar about? It's about machine learning, or the ability of computers to analyse data, learn from trends and solve problems. It's been employed around the world across a vast array of sectors and to varying levels of complexity for years. But are we harnessing the power of machine learning in social protection? So in today's webinar, our experts discuss how aspects of this branch of artificial intelligence have already been applied in the sector and the possibilities for application of machine learning beyond that. Data sharing and security are critical and often controversial topics in this space, and the debate on how regulations can be enforced and maintained will also be woven into the discussion. So to introduce our panel for today, we've got 4 excellent speakers. Our panel is split between the UK and Kenya. And to give you a very quick introduction of who will be speaking today, we have Richard Chirchir, who leads Development Pathways Digital Technology Team as a Principal Digital Technology Specialist. Peter Thirikwa, who is a Management Information Specialist on the Hunger Safety Nets Programme in Kenya. And Katelyn Cioffi, who is a research scholar at the Centre for Human Rights and Global Justice at NYU School of Law. And last but not least, we have Boniface Kibicho, who is a Senior Digital Technology Specialist at Development Pathways. And it's my pleasure to welcome all of our panellists today. So I just want to remind you that we'll go through all of the presentations, but we're really keen to get a conversation going at the end with a lively Q&A. So if you have any questions as we go through, please just pop them in the Q&A box at the bottom of the screen. There's a button and it will pop up and then you can add your questions in there. And if you have a specific person who you want to address your questions on the panel, then please also add their name and then we can direct those around effectively during the Q&A session. So without further ado, Richard is first up. And so just to give you a bit more background on Richard heads up our digital technology team at Development Pathways. He has over 20 years experience in advising on solutions in the social protection field around the world. And Richard is going to talk about the power of machine learning. So I will stop sharing my screen and ask Richard to go ahead and kick the webinar off. So thanks very much, Richard. Over to you.
Thank you so much, Laura. And good morning, good afternoon, colleagues from across the world. I think it's a pleasure to start this webinar to frame the discussion on this very interesting topic on machine learning and application to social protection programs. So I think Laura already explained the terminology. There will be other definitions that I want to dive into to be able to make the discussions a bit easier when the other presenters will bring their experiences. So I think in terms of the typology, There are three main types of machine learning systems. We have supervised learning, unsupervised learning, and reinforced learning. So what we mean by supervised learning is algorithms that utilize probabilistic methods. Probabilistic means score-based, weight-based, as opposed to rule-based, which are called to make prediction of using labeled data as reference. Within the social protection language would be, or examples. Key examples include, for example, if you're analyzing beneficiary complaints, you would be getting the data on beneficiaries, but categorizing them into particular, labeling them into particular data aspects for the machine to be able to analyze for you and to give informed meaning. So on the other hand, unsupervised still employs probabilistic methods, but it's used to separate data into clusters. For example, in the context of social protection program, you can get complaints from your beneficiaries in multiple channels, say, for example, emails, short text messages, chats, and blogs. And then there would be a sentiment analysis, which could be employed to mine that data and to be able to then analyze it to derive some patterns, insights, points, which would actually give a bit of meaning. And the final typology is reinforced learning, which means employing the algorithms to build a policy that maximizes the cumulative value. And I think this is typically employed in quite advanced AI machine learning implementations, for example, self-driving vehicles and robots. So I also wanted to bring in this distinction because some of the participants, for example, have worked with a number of information systems. In social protection sector, they're called management information systems. So machine learning is not an information system. In other words, it doesn't follow, information systems follow a set of predefined rules and procedures derived from program operations manuals or design documents to perform specific tasks. For example, we can have an information system function to determine the beneficiaries who are due to exit a program. And there are multiple other examples. Say, for example, generate a payroll and many others. It's also not data analytics. It relies heavily on data to derive patterns, insights, decisions, but it's not a regular system for processing data to obtain information. Machine learning is not also dashboards for your standard report or exceptional report. This can often be designed using information systems, warehousing models, analysis tools, and others. It's also not a deterministic query, meaning it's not a rule-based query. For example, you do not write a query to say, for example, tell you the number of beneficiaries, the payments dispersed, and many others. So that's effectively the definitions of machine learning. In terms of the functions within social protection delivery chain, which could be applicable or which could be used to support machine learning. Examples include, for example, identification and registration. So we know, for example, what that particular function does. You identify a beneficiary, you register them. There is typically a function associated with eligibility assessment, determining whether the beneficiary, for example, is eligible based on poverty analysis and vulnerability. Enrolling beneficiaries means preparing them so that they can get access to the benefit by either preparing, say, for example, opening a bank account, payment and service delivery, supporting the beneficiary by generating the payroll, exchanging that payroll with a payment service provider and ensuring that they access to the benefit. Grievance and complaints function deals with receiving complaints, resolving them, and providing feedback to the persons who raised the complaints. Beneficiary management is a function related to managing of beneficiaries based on program rules, compliance, updates, referrals, case management. And finally, monitoring and reporting is a cross-cutting function, which means generating notifications, analyzing the data to actually understand the functionality of the program as a whole. So this month, we're going to look at machine learning and the way it can be employed to support all these social protection functions. But before we do that, we need to ask ourselves, what are the benefits? What is the overarching goal? What are the issues within social protection programs that can be addressed by putting in place machine learning systems. So that effectively, if you cross two triangles, you get in the middle a very beautiful diamond, which is the focus of quality, speed, beneficiary decisions that need to be addressed or derived out of putting in place a functional system for social protection. So there are four main types of data issues that typically need to be addressed. The first is data validation. That's the process of checking for completeness of data, applying consistency checks, data deduplication, comparing them with some dictionaries. The other aspect is data verification. And this effectively means processing of data, comparing it with external data sources. Say, for example, if there is another government registry, an information system, say, for example, national ID and others, you're comparing the data for social protection scheme against that. We know that, for example, once you collect the data in many registries, that data can be outdated very quickly. So there is need to have an updating process. And nowadays, it's possible to collect the data, but more importantly, that data update can also be received from other administrative data sources. And finally, it's analysis, which means processing the data to provide deeper, faster, and complex insights. So what we're going to look at next is how these four data issues, which are relevant, and sometimes you have a number of social protection programs applying their information systems to be able to answer this. But we're going to see, for example, how machine learning is able to address this. So in terms of identification and registration, machine learning systems can be able to support three main data issues, or address three main data issues: verification, validation, and analysis. And examples include deduplication when it comes to identification. So in many countries where there are challenges with the national ID in terms of the coverage, you can employ, or machine learning systems can be employed to learn the data culture so as to improve data quality, image processing, computer vision, facial and voice recognition. So it can help in terms of identification and support the quality without even in a country where, for example, there is no national ID, by understanding exactly the name, patterns, and other unique attributes among the population, it should be possible to train up the machine, the model, to be able to give as much accuracy as possible in terms of identification of the potential beneficiaries. The second aspect in terms of eligibility, it supports validation and analysis. And that means data, by clustering the data through unsupervised machine learning techniques, it's possible to tailor methods to support various vulnerability categories. Third is enrollment. When it comes to enrolling the beneficiaries, again, preparing them to be given support. Machine learning systems can be able to support validation analysis. That means algorithms with appropriate safety risks can be utilized to analyze the patterns. And then when it comes to payment and service delivery, it can support very strongly the fraud detection. For example, post payroll checks would be helpful in terms of dealing with supporting that. Grievance and appeals mechanisms, case routing, prioritization, predictive case management becomes very powerful aspects that can be supported by machine learning. In terms of beneficiary management, machine learning systems can help in terms of risk assessment to determine those at higher risks and in need of additional support, predictive modeling on elements such as graduation. And of course, finally, monitoring and reporting. Machine learning systems can support validation, analysis, and updating real-time data analysis to identify trends, automated reporting, use of M&E data for predictive modeling. So is it all rosy with machine learning systems? Just like any other newer technologies, there are associated risks. So there are regulatory challenges. For example, the Council of European Union, for example, has a very recently adopted artificial intelligence, but there are restrictions in terms of the use of AI for scoring and eligibility. So there would be, you would need to analyze, for example, regulatory environment in your country before making a decision to do that. Data privacy and confidentiality is also a crucial issue. partly because every time you think about AI and machine learning, it's also important to think about undertaking data privacy impact assessment, because it deals with a lot of data that you're going to, and some of that data may be privileged data. And then, of course, because machine learnings rely on a lot of data, if there is a poor quality or biased data, it means the machine can give wrong results than what is actually planned for. And of course, like any other IT system, security, there are serious security concerns with the implementation of the machine learning systems. And of course, it requires a good strategy, data science specialist, and it's an emerging technology to get the right strategy that you can employ within your social protection program. Thank you so much, and look forward to the next session. Over to you, Laura.
Thank you very much for that, Richard, and for keeping some good time there too. Brilliant. So in case you'd like to revisit Richard's presentation later as well, the team at socialprotection.org will circulate all of the presentations from today, so you can just focus on what the panelists are saying. So brilliant. Next up is Peter Thirikwa. Peter has 18 years of experience in the development and implementation of management information systems, and he's going to take us through some of the different applications of machine learning from the Hunger Safety Net program in Kenya. So HSNP is an unconditional government cash transfer program implemented in the 8 poorest and arid counties in Kenya. For a little bit of background, but I'm sure Peter will be able to give us some more information on that. So welcome, Peter. Please go ahead and share with us the interesting information you've got to share with us today. Thank you.
Thank you very much, and hello everyone. So thank you, Richard, for setting the pace. I'll take you through a few examples of what it is that we are doing here in HSNP in terms of harnessing machine learning, and of course, in terms of improving implementation arrangements and operations across the program, and also to aid in meeting the objectives of the program. I'll highlight a few examples. So this is the first one, and Richard did speak briefly about it in terms of data deduplication. So here we employ supervised learning to do data deduplication. And this is because when we do registration of data of households, of which we do census-based registration, we get a mix of data where we have households, quite a number of them, having no unique identifiers, or households that do not have national IDs. And part of the first activity we do in data cleaning is trying to identify these particular duplicates. And what we do is for those that have IDs, then we would use a rule-based process, like what my colleague did mention. But for the households that do not have unique identifiers, then we employ probabilistic deduplication techniques. And these are techniques in machine learning that employ supervised learning, whereby a training data set is used to train a classification model. Like you can see the image on your right would simulate, for example, this would be households like A is duplicated 5 times, B is duplicated several times. So would train a model on a sample case of data, looking into the culture and to how the households are organized. And the model is able now to identify any other duplicates within the database, of course, to an acceptable probable percentage. And this would be over 80 to 90% in terms of its accuracy. So this is one of the applications that we are running. Another one that we do in terms of machine learning is natural language processing. So we deliver key program information through a trained machine learning chatbot. And this is a supervised learning model. So the chatbot is designed to understand and respond to human language in conversation. And for those that are keen with the current trends, you already know of the Chat GPT that has grown popularity in the last few weeks. So this is like a baby Chat GPT, which is only trained with regards to program information. So the model is trained to handle common inquiries and requests with regards to the program operations and with the capabilities of extracting specific data from the database. So for example, a beneficiary might ask, when was the last payment made? So the machine should be able to understand such a question. It should be able, even if it needs to query some specific data sets from the database, and respond in more human nature back to the beneficiaries. However, we oftenly retrain the model with relevant and updated program-related information in order to keep pace with the program implementation activities. So that, for example, if we have a specific activity we are planning for February, for example, or we are planning for March, then that information is added, we retrain the model, and it is able to provide that particular information to anyone who queries. And what it is that we did, we integrated it onto our Telegram bot so that it is easy to reach out and to interact with beneficiaries. We also have some predictive prediction models. And one of the key components of HSNP is scalability. And this refers to the ability of the program to expand and contract depending on preset triggers. Now, HSNP scale-up triggers depends on the drought situation in the country. So what happens is additional households are added into the payroll during severe and extreme drought seasons using objective satellite data on vegetation condition that is collected and analyzed on a monthly basis. Now, in order for us to be able to plan and budget and also to eliminate emergencies, what it is that we have is we are piloting a prediction model. So this model is a supervised prediction algorithm that is using available rainfall and vegetation data dating back to the year 2001. And it is able to predict to an acceptable probability the situation of the drought up to 6 months in the future. And on your right is a sample output from the model. So it is trying to follow the trends over time, looking at the rainfall and the drought seasons and trying to draw or predict in the future what it is that is likely to happen. Another model we are also working on is the machine vision model. So the program has implemented an image classifier, and this is to be able to validate the satellite vegetation condition index and also trying to eliminate biasness in field monitor drought observations. And this is through using live imagery. So we want to, for example, at a particular GPS coordinate, at any moment in time, we have trained a model such that if we take a picture, it is able to classify the drought scenario for that particular data point. And that data is used to be able to validate the other readings like the vegetation condition and also observations submitted by the drought monitors out there in the field. And we're also hoping to further improve it to include livestock condition monitoring so that by just having a picture taken, the model should be able to know this. For example, this cow is at this particular stage in terms of how we will train the model to be able to accurately read such data. Another example, we are also doing data clustering, and this is very common across program implementation. So the program is also using unsupervised machine learning algorithms to look for patterns or correlation in HSNP data. So we do data clustering as part of data exploration to aid in program planning and field operations. Now, clustering also helps in extracting data insights for guiding management in making critical program decisions and policy. And for the implementation individuals in this particular webinar, you all know that dynamics change in such programs. And what it is that we do is we take the data, we cluster and try to draw conclusions out of it. And these conclusions are written up and they are used to guide the management in whatever decisions or policy that is needed to be made. So insights that are garnered are also used to shape future programming within the program. So that's what I have for you today. Hope to listen to the next presenter. Thank you very much.
Thank you very much, Peter, and thank you for sharing some of the uses of machine learning in the Hunger Safety Nets program. That was really interesting. So everyone, remember, if you have any questions for Peter or any of the other panelists, please don't forget to put them in the Q&A. I can see there's some going in there already, which is fantastic. So now we're temporarily leaving Kenya, and we're moving over to the UK, where our next guest, Katelyn Cioffi, lives. And so she is a human rights lawyer and research scholar at the Centre for Human Rights and Global Justice at NYU School of Law. And she works there on the Digital Welfare State and Human Rights Project. And so Katelyn leads the project's research and advocacy on digital ID systems and their impact on human rights and social exclusion. So welcome, Katelyn, and yeah, over to you.
Thanks very much, Laura. I'll just share my screen. Great. So thanks very much for that introduction, and thanks also to Richard and Peter for two really fascinating presentations. I certainly learned a lot and look forward to the discussion later in the program. My presentation today is going to take us in a slightly different direction, and I think pick up a bit on where Richard left off on some of the risks of using machine learning in social protection systems, but also looking slightly more broadly at the use of emerging technologies and how we can truly safeguard human rights in their implementation in programs like social protection. And I think it's really clear from the two first presentations that technology can absolutely have a positive effect in things like expanding access to social protection, ensuring that programs are designed and reactive to beneficiary needs, and overall improving the enjoyment of human rights for vulnerable and marginalized groups. However, even well-intentioned programs don't inevitably have a positive effect on access to social protection and human rights. And I think it's important when thinking about the risk calculations that we acknowledge some of the emerging evidence on the impact of human rights of some of these new emerging pieces of technology. And again, I'll go slightly broader than machine learning in this this presentation, because it's been clear from the evidence that has come out already that technological systems are not neutral tools, but instead they often reflect political, social, and economic realities of our societies. And this can include things like systemic bias and discrimination, gender inequality, and digital divides that may end up being deeply embedded into the design and the data that underline some of these new technologies. And many years of kind of tech experimentalism shows that if we ignore some of these deeper issues, it can ultimately frustrate the overarching goals of systems of social protection, which are often targeted at alleviating poverty, improving enjoyment of human rights, and really focusing on making people's lives better. So I think this is a really important component when thinking about how and when to use machine learning. So my presentation will cover kind of three main topics. First, I want to talk about some of the emerging evidence on the impact of emerging tech on human rights, and drawing specifically on our work on digital ID systems and their integration into public service delivery. So this is something that often leverages aspects of machine learning, such as deduplication, but is also slightly broader as a kind of foundational piece of technology that will enable different components of machine learning in the future. Second, I want to talk about what we can learn from some of this emerging evidence. What are the key questions that need to be asked when designing any sort of new technological innovation? And also, what are the key human rights concerns that we need to consider when dealing with machine learning in social protection? And then finally, I want to point to some of the current gaps and barriers to progress in this area and things that are going to prevent government and program officers as well from being able to truly safeguard human rights in the implementation of new technologies. So to start with, drawing on our work from digital ID systems, which, as I mentioned, often form a base layer for many new technologies, including machine learnings, because these are sources of data that will inform a lot of the machine learning sets that will be implemented. And they hold highly personal and personalized data. And looking across the world at different implementations of digital ID systems, in a recent report, we identified 3 kind of major groups of concerns. And I'm happy to talk about some of the specifics of this later in the presentation, but the 3 kind of themes that we identified is first, that the use of emerging technologies can often increase efficiency, but it can increase the efficiency of human rights violations and issues, just as it can increase the efficiency of financial and implementation aspects of the program. So some examples of this is that we see the replication of issues like discrimination that are present in the broader society and are deeply reflected in some of these new digital technologies, where the groups with lesser political voice, lesser economic power, are often further marginalized through the implementation of new technologies. These systems can also facilitate surveillance, particularly of marginalized and vulnerable groups, that can be easily misdirected for many different purposes. And they can also create new burdens on individuals to ensure that they are making themselves readable to digital systems in a way that will guarantee access to their rights. Another issue with a lot of the digital systems that we looked at is that they can also introduce novel forms of harm, and the use of data sets across different government initiatives can actually just replicate these forms of harm across different areas of public services. So this can lead to what activists in India have often called civil death, when an individual ends up being completely shut out from systems of social protection, but also from systems of healthcare, education, and other areas of vital essential services, because they have become so dependent on the use of data sets or digital systems that just kind of compound and replicate some of these harms. The third and final issue that I just wanted to touch on is this issue of whether the digital systems are actually delivering on their promises of efficiency, of improving, the speed of decisions, the effectiveness of decisions, the accuracy of decisions. Because what we've seen in a lot of our work is that we're not using the full power of the evidence and the tools that we have to evaluate whether these systems are actually achieving the goals that we all hope that they will. So are they actually expanding access to social protection systems? Are they improving the speed of decision making? Or are they actually deepening exclusion and leading to people being further left behind and further marginalized from these vital systems? And I think the evidence base on this is rapidly expanding and quickly developing over time, but there are still a lot of unknown questions. And I think that that is a major stumbling block to the protection of human rights, because decisions are being made and a lot of experimentation is going on, but we don't yet have the evidence base, and we haven't fully used the tools at our disposal to evaluate things like value for money, effectiveness, and compliance with human rights norms. So what can we learn from some of these issues that have emerged over time? I'm sorry, I'm just having a little trouble with my screen. So I think this leads us to a place where we can begin to start asking some of the right questions. And the first thing I'd want to emphasize here is that a lot of emerging technologies are looked at in isolation from the broader context. But what we saw, particularly when it comes to digital ID systems, is it's important to recognize that multiple rights are being implicated in the use of these systems. So even if a system is being implemented in the social protection system, it may ultimately affect how someone accesses healthcare. It may affect how they access education. And so it's important not to have a kind of a machine-centric approach or a technology-centric approach and think about how you safeguard human rights in the context of a specific predictive algorithm or a specific machine learning tool, but instead to think in a human-centric way about the different tools that are being used on an individual person, the different pieces of data that are being extracted and they're being used to make decisions about their access to rights. And I think this is a reversal of the way that we often evaluate programs, which are kind of focused much more on a specific government initiative. And instead, I think it's important to look holistically across, different systems of social protection, of healthcare, of education, and other rights to see how individual people are being affected by many of these different tools at once. A second issue is that we are often failing to use the existing human rights framework when evaluating some of these programs. So I said I'd pick up from what Richard was saying about some of the risks in his last slide. And I think we should also think about some of the human rights risks at the very beginning of the program. So are we thinking about whether the program has the use of the machine learning has clear rules? Does it satisfy the conditions of legality? Is it really necessary for some of the applications that we're using it for? And this is a core component of human rights evaluations, in that we know that there can be harms associated with some of these systems, but in order to evaluate whether or not they're truly necessary or proportionate, we need to be able to balance those against the achievements that we expect to see. We also need to think about the importance of data sources, whether they reflect bias and discrimination, whether they've been obtained with the consent and knowledge of individual people. We need to be quite careful about experimenting with some of these tools on programs that are designed specifically for vulnerable and marginalized groups of people, because these are those who are often most in need of assistance and access to certain rights. And so any experimentalism that will put those rights in jeopardy needs to be approached with extreme caution. And the final point is really about transparency, consultation, and participation, and ensuring that when we use new tools and emerging technologies, we're doing it with the full knowledge, with consultation with the affected communities, and giving them a real opportunity to participate in some of the decisions and to decide whether these tools are the right ones to be used, and also whether or not they want to consent to their use when it regards their individual rights. And then the final slide is just about what some of the current gaps and priorities are when it comes to safeguarding human rights in emerging technology. And I think the first priority is really expanding the evidence base. And I think these presentations were a great example of that, of talking about what we're learning from early uses of emerging technology, sharing some of the successes, but also sharing some of the failures. And I think we've seen examples in other countries, for instance, in the Netherlands, where the use of algorithmic predictive models in different areas of the social welfare state actually led to violations of human rights. So I think sharing this learning and using that evidence base to make decisions in the future is very important. A second aspect is policy and regulation to proactively address some of these emerging concerns. And Richard mentioned the EU AI Act, which is developing a kind of typology of risk assessments against different types of technologies. And I think that's very important, that this is not, a burden that is being shifted to program managers when they're designing their programs, but that there's a more ambitious regulatory approach to identify areas of high risk and areas where we think that these tools should or should not be used regarding access to social welfare systems. A third point is the importance of remedies for rights violations, especially in the context of tools like machine learning, where there are unique stumbling blocks for individuals to understand decisions that are being made about access to their rights, which make it difficult for them to access traditional remedies. And I think that's an important case study that's happening right now in Uganda, where a group of civil society organizations are actually challenging the use of the national ID in access to social protection, and seeking a new remedy for those who have been excluded. And then the final 2 points, just quickly mention. The first is the transparency and consultation, which is incredibly important and I think an often under-resourced aspect of use of machine learning. And it's important that that becomes a new priority to ensure that these models are being explained and consulted on by affected communities. And a kind of a last point that I always like to mention in these discussions is the private sector involvement in developing some of these tools, in using proprietary technologies, and also in housing a lot of the data and information, but also becoming essentially customers for some of the information that is being collected, which brings its own risks, and I think is something that needs to be kind of addressed and considered whenever considering the use of these tools. So thank you.
Thank you very much, Katelyn. It's so important. We've looked at a lot of the details. It's so important to take that step back and look at the bigger picture and see what kinds of risks are associated with using this kind of technology. Brilliant. Thank you so much. And yet, just a reminder for anyone joining later or anyone who wants to listen to Katelyn's presentation again, a recording will go out after the webinar has finished. But yeah, and now we can move on to our final panelist, who is Boniface Kibicho. And Boniface has a background in design and development of social protection management information systems. He works with the team at Development Pathways, and he has 12 years experience in .NET and other web technologies. He's currently got a focus on AI and machine learning, microservices and cloud technologies. And so welcome, Boniface, and over to you.
Thank you, Rora, for that, and welcome everyone.
You're welcome, Boniface. Are you able to put your video on as well?
Sure, thanks. Sorry for that.
Thank you very much.
Okay, thank you. So I'll be concentrating on how one can design a machine learning model for an SP scheme, and I'll just be looking at the how to, the step-by-step on what you need to consider and what you need to do. And the first thing you'll need to do is that you'll need to do the planning of your machine learning model, and then to be followed by the data exploration. I'll be going to this on details, and you select the algorithm that you need to use for this. And then the next thing is that you need to do the data cleaning and preparation of the training and the test data that you're going to be training your model on. And then you need to train and evaluate the model, and then you keep training and evaluating the model. Then you need to do the model optimization and parameter tuning, where you need now to reduce the number of parameters and the cost that you need to use when the machine learning model is making the decisions. And lastly, we look at the deployment and the monitoring of the machine learning model after deployment. So what do you start with? So the first thing you need to do is that you need first of all to identify the organizational need that need to be solved by the machine learning model. At this point, you'll need to have a clear problem statement and the goals and the objectives that need to be achieved by the successful machine learning model that the machine learning model will solve. The next thing is you need to identify the source of your training data, and also you need to consider the quality of the training that you need in the training, in the development training of the model. And the case here to consider is that you need large amount of data and high quality data that you train your model, that this data should correlate to the larger production data that you will deploy your model to. At this point, you also need to analyze the data that you are going to use in machine learning. You need to identify the features of the data, the different components, so you can easily group the data. And also, of course, this will be dependent on what you need to achieve. The next thing is you also need to identify the model, as Richard explained. Which model are you going to use in solving the problem? There are different models, as you can see on the right. You have the supervised models, you have semi-supervised models and supervised models, and also reinforcement learning model. And under these models, there'll be now the very algorithms that you need to identify that you are going to do. For example, if you want a classification or a prediction or forecasting, then you are going to choose a supervised model. In case you are looking at things like clustering, then you go for unsupervised models. And then in case you want to use a feedback loop and reinforcement learning, then you go to the last model, where this one is going to use the trial and error mechanism, and then you have the reward signals, and then the machine will learn from that. After determining which model you are going to use and the algorithm under that model that you are going to employ, then you also need to reach a place, depending on the expertise, and select the language that you are going to use in developing your model. We have the different languages that are available, currently being used. Python is one of the most popular, followed by R. Java and JavaScript are also being used, C++ and C#, ISP and Prolog, among many others, depending on what you are conversant with, and maybe what also is available to meet your need. Lastly, you also need to consider, even before development, on how you are going to deploy your model after development and after training it. We look at the last point in detail when you're looking at the deployment and monitoring. Then, during the first step of the second step of cleaning and preparing the machine learning model, you'll need at this point to prepare a very large volume of high quality data, because you need enough data for the machine to learn from. Because if you have a small set of data, then your machine will be having a bias, and it will of course lead to a higher margin of error. Then after selecting the data, then you need to do the data pre-processing, where you need to do the data cleaning, and here you need to remove the partial data, the data with missing columns or elements, incomplete data, the duplicates. And at this point, you may require data science expertise, maybe a data scientist. And this is actually a very laborious exercise that we need to be considered if we are going to have a successful model at the end. You also need at this point to have the feature engineering, where you are going to have the keyword exploration, keyword determination, in case maybe you want an NLP model, among many other things that you need, and also the normalization of data, and where you also need to transpose your data from text to keywords or numericals for faster model. Then after you select your model, when you're preparing this data, you also need to consider what do you want to do with this data, because different models require different data sets. For example, for supervised model, you require labeled data for input and also for output. And then, so you need to prepare that data to achieve that aspect. But for something like unsupervised data, then you may not need the labeled data, but then you may have the hybrid of the two in case you want the semi-supervised models. Then after you select, you prepare this data, then you need to split this data into two. The first set of data will be the training set, where you are going to train your model on, and then the testing set. For testing your model, you need to test it with previously unseen data that you've not passed it to the model, meaning it has not learned from it, to see how it's going to perform, the degrees of error and the accuracy, the time it takes, and how fast or slow is it in generalization. And here, it's usually recommended from the data set that you have the 20% for training, and for testing and evaluation of your model, you have approximately 80% of your data set. Then the next thing is during the training and testing and evaluation of your model, then you need to do two things. You need to pass the data that you've prepared to the model that you've already developed using the language that you selected previously, for it to either find pattern, to classify, to make prediction, forecast, and so on and so forth. Then the model will learn from the data that you've passed to it to accomplish the set of tasks that you want to achieve through this model. And important to note is that the more you train the model and the more time it takes in learning, then you are going to have better results. every model, usually after development, it has a large degree of error, and that's why you need to do the model optimization and parameter tuning by lowering that degree of error to have more accurate predictions on previously unseen data that is passed this model. And the parameter tunings is changing the parameters that you pass to the model. That this is the data that has been developed by the programmer, not the data set that you prepared, but the variables. How many variables does your model require to make a decision? So this is a parameter tuning, because we have so many parameters, but probably it's 2 or 3 that are required to make the decision. Or parameter tuning, where maybe you may need to combine several parameters into one for faster and better prediction. Then the last step will now be the deployment and the monitoring of your model. Usually the model will be developed offline or locally, and with a prepared data set and the training set of data. And then deployment is the process you're going to move this model from your development environment to a live or production environment. Of course, we also consider we are going to have staging environment and so on and so forth. And then it's going to work with previously unseen data sets. And then once you deploy it, the most data set will be increasing on the production environment, then the model should learn from it. However, it is at some point the data may change and significantly. And at this point, you need to have periodic updates and retraining of your models as the data evolves, and also as the degree of error is assessed on large data sets. And there are different modes that you can deploy your model on. You can be having your servers, and then you can host your model there. You can also consider using cloud-based services, Amazon Web Services, Microsoft Azure, Google Cloud Platform, and so on and so forth. You can also deploy it on containers, and here is where you can have different, for example, as Peter explained, you can have different models to achieve different sets on one single program. So the best approach would be using containers, and here you can use Docker or Kubernetes orchestration platforms, where you can deploy different models or sections of models on the same, in different containers in the same hosting. Then that way, when you are updating or you are retraining your model, you're not going to be affecting all the other models that are performing other parts of the system. You can also have the edge device mode of deployment, where in this type of approach, you are going to be using IoT devices or smartphones to do the machine learning and perform the different tasks. Or you can have hybrid deployment, where you can have a combination of all the above. Or you can, if you don't have the resources, or you want to use other platforms that are dedicated in offering this, then you can use the TensorFlow, Clipper, or Seldon, which are, among others, which are model serving platforms that you can host your models there, and then you can use that. There are many other factors to consider when you are choosing the mode of deployment. One, you have to consider the legal requirements. For example, in case it's personal identifiable data that you want to host, then there are limitations, maybe there are government controls, and so on and so forth, that may limit where you are going to host your data. And that's all from my end. Looking forward to the next session, where we are going to have the question and answers. Looking forward to it. Thank you, everyone.
Brilliant. Thank you very much for that, Boniface. And thank you very much to all of our panelists who've made my job very, very easy by sticking to time. Absolutely brilliant. And some really interesting points made by all of you there. And I can see that we've got loads of questions coming in the Q&A. So I'm going to begin looking through those, and we'll direct different questions to different members of the panel. But if you have, if any of the panelists, if all of you would like to switch on your videos, that would be great. And if I direct a question at one of you, but perhaps it's not the one for you, please feel free to pass on that to another member of the panel. Alternatively, if you have extra notes to add to someone else's response, then please do chip in and let me know if you want to share your response too. But to begin with, I've got a question here for Richard, and the question is from Paul Crook. And he asks, how are we using machine learning and wider technology to take forward localization and good governance? Richard.
Well, it's a tough one. Laura, can you hear me?
Yes, you've just gone on mute, but we can hear you again now.
Okay, thanks. So, yeah, I think that the big concern, I think which I saw in the question was the risk around centralization and not involving the communities, issues about good governance, issues about localization. I guess, I mean, if you look at it from the context of social protection, you're looking at it broadly in terms of, will these machine learning systems support better decisions, faster decisions, addressing the needs of the beneficiaries? The answer is yes, from that particular perspective. Of course, as I explained earlier, there are risks associated with implementation. And the bigger risk is around the data quality. That's a major issue. I think some people have asked me about registries, particularly social registries, and whether the machine learning systems could be also used. And I think my response to that is, the answer is yes, you could employ machine learning. The main depends on the objective, it depends on the strategy you're using to do it. If you look at the example that Peter has been highlighting in terms of HSMP, they are addressing multiple other areas where you would have needed more money to do research to be able to answer some questions. So the answer is yes, if we use employee machine learning to be able to better be inclusive, be responsive to the needs of the beneficiaries, understand better their complaints, design better our schemes, then of course we are improving also overall the governance of the programs. And also, yeah, so we're working on that. So I think it's in that particular light. If we use them for, in a negative light, maybe you have poor quality data that creates biases or have algorithms that lead to exclusion, then of course we are employing them. We are employing technology in our own way. And I think that's why, for example, there are legislative frameworks in place that are there to put in place these safeguards. Over.
Thank you very much, Richard. Actually, there is another question in the Q&A that has a similar theme, and it does talk about how we can overcome bias. This one, I wonder if perhaps Boniface, you might be able to have a response to this one. It's from John Ure, and he asks, if machine learning requires training of algorithms, how far does this offer ways to overcome bias?
Thank you. I think here the most important thing you need to consider is you need to have the data set and enough data for training and enough time for model training. Because if you have small data set and then your model just learns from the small set of data, then when new type of data comes, then it will not be able to use that data. For example, in case you don't have data for the marginalized groups, and then you don't train your model on that, then even if you are going to have data for that, then it's going to be long decision making or long classification, or even rejection in case you're talking about social protection and maybe cash transfers because of that lack of data. So the best thing would be have data that covers the entire scope, or that reflects, the data should be similar. The training and testing data should be similar to the production data. That should be the minimum.
Okay, thank you. Thanks, Boniface. And I've got a question here from Anna McCord as well. And this one is for Katelyn. Katelyn, what is the human rights violation issue in Uganda relating to the proposed use of ID for social protection registration?
Sure. So I just put something in the chat as well for Anna, but the main issue in Uganda is that one of the key social protection programs, which is targeted at older persons and which provides an unconditional cash transfer, a few years ago began using the national ID database as the sole means of identifying beneficiaries for the program. So any older persons who had been unable to register or who had failed the biometric deduplication process, or even some who had lost their ID or couldn't remember their national ID number, were essentially excluded from accessing the social protection program for the elderly. So the civil society organizations in Uganda are challenging this policy on human rights ground because it has frustrated access to what is essentially the only means of social security for this group of vulnerable older persons. And that is the ground that the policy is being challenged on.
Okay, thanks for sharing that, Katelyn. The next question I have, this one is for Peter, that's just popped up in the Q&A. And it's about the use of machine learning for deduplication in the HSNP. You mentioned an 80 to 90% accuracy. What's the methodology that's being used to measure the accuracy?
Thank you very much. So for accuracy, as Boniface spoke to, the models that you choose, you are aware of developing measures or extracting the measures from the models. So for example, if you do a deduplication algorithm, there's a way you can be able to measure the accuracy of that particular algorithm. But also you can be able to sample, for example, if I do the algorithm, I deduplicate 30 records, I can be able to confirm or sample this particular records and see how accurate is my model identifying these duplicates. Is it following the learnings or the trainings that the model has been taken through, so that you can be able to see how the accuracy of that particular model is performed.
Peter, sorry, did you completely answer that?
Yes, sorry. Yep.
Yeah. Okay. Thank you very much. And okay, so we also have a question from someone who's clearly keen to be more in tune with what's happening in machine learning and perhaps get involved. And that question is from Ilkar Zabaliev, and who asks, which machine learning programs would you recommend learning? And are there any training centers that you would recommend? And that question could be for any of you who've already been involved in this work, but possibly also for Peter. Peter, do you have any recommendations?
I can give it a go. Number one, I have a preference for Python, for example, as a language, because there exist a lot of libraries that are already available that can be enhanced or can be used for doing machine learning. But of course, now that means you'd have to learn Python as a preference, of course, for me. But if you're good in R or in other languages, then you can also find some libraries that you can be able to use to implement machine learning. But in terms of courses, for example, for me, I did a course on machine learning from the University of Texas at Austin, that is in the US. So you can be able to find specific courses that are aligned to machine learning. Like what I did was specifically aligned to machine learning as an example. But I'll also post a few more examples as the discussions continue on places that you can be able to get this particular information or go for courses there. Over.
Brilliant. Thanks for the advice there, Peter. We have a question in the chat that is for Boniface from Joe Zarua, and he asks, have you dealt with data augmentation, and if so, was there a lack of labeling, and how was that dealt with?
This issue, especially for data scientists, you're definitely going to meet it at one point or another. and it also affects the supervised models largely. And then that means you need more time when you are developing your model, and you may need to try to source more data, and it becomes a problem if even your production data is unlabeled. Then you may have to consider the approach and the algorithms that you're going to use to do the feature engineering, for example. And then at this point, you can also try to use tools like, I think there's also a question on that on AutoML. You can use tools that are out there that can try to make your process faster and easier when you are doing the data labeling. We have tools that automate for that you can consider. But in case you don't have access to that, then you may consider trying to consider the approach and the algorithm that you're going to use, because data, machine learning learns from the data. So data is key for a successful model.
Thank you, Boniface. We've just been asked a slightly more philosophical question. So I'm not sure who would be best placed to answer this, but I'll put it out to the panel because I'm sure you've all got views on it. It's from Richard Asai Bofa from Ghana. And Richard asks, in the process of using machine learning in social protection programs, how are we going to address the increase in fear of technology and disrupting and replacing existing jobs? Does anyone have any thoughts on that kind of topic? It's a big topic, I know.
I guess it's a broad that affects other technologies, not machine learning alone or artificial intelligence. So I think it's a bigger global issue, which is not limited to social protection alone. I think it's an issue related to growing area of newer emerging technologies, the desire for automation, the desire for efficiency, the desire for getting things done quickly. So I think we're not going to run away from that. And I think the other side of that in terms of the philosophy would be, I guess, for people to be trained on how to be able to train, build these models, right? Because then the jobs will be in that particular space. Yeah, in terms of the creativity. So I think that's what we can say in terms of that. But I don't think, for example, let's say social protection sector will be left behind because of the fear of losing jobs because of the newer technologies. Let's also remember these technologies also make things very efficient. Information systems alone, if you think about payrolls for large schemes, and I want to give an example of, say, Pakistan, with a payroll of, say, 7 million beneficiaries that you have to process monthly. It's through automation that you can get the efficiency. And with even large data sets now in the registry, if you have a machine learning model, you can gain even more stronger insights and have maybe a better scheme that can be put in place. So I cannot run away from this. I think the reality is just to learn the new technology so that we can employ and minimize the risks and put in place correct strategies to implement them. Building upon the point that was made by Peter earlier, I think also besides formal learning institutions, that we can go to their multiple resources online. There are groups on LinkedIn working on this particular topic and all that. So there's a bit of, I think knowledge is everywhere. I think this is one avenue of sharing this knowledge, but there are multiple other platforms. You can go to formalized institutions that are teaching, but also you can also access a lot of resources, which I want to presumably, for example, this platform will then generate even additional discussions, and for others will also contribute from this particular group into sharing their knowledge and their experiences. Over.
Thanks, Richard. There's certainly a lot we can learn from other sectors as well. The next question is for Katelyn. Christopher Mwembe asks, from a human rights perspective, how do we ensure marginalized communities in hard to reach communities with poor network coverage can benefit from emerging technology or new models to promote transparency?
Yeah, I think that's a great question, a really important one. And I think just to kind of pick up also on the previous question, I think a key decision point when implementing any sort of machine learning or new tech is what is the overarching goal of the program and how does that piece of technology fit into it? And I think we should embrace the possibility that there are times when the piece of emerging tech or the piece of machine learning isn't necessarily the best tool. So I think, the question about jobs and, whether or not things will be done better and more efficiently through algorithm, again, is like a much broader topic. But I think particularly in the social protection sphere where, we have a lot of evidence about different approaches that may work, and where we have a lot of rich experience about engagement in different ways of engaging communities through face-to-face programming, I think we shouldn't abandon that in favor of, just using machine learning. So I think there should still be space for some of these older tools that are maybe not seen as exciting or as kind of novel to still be used and to be used in a complementary way to new pieces of technology. And when it comes to marginalized communities and hard to reach places, I think that question of necessity really comes into play here, which is if our goal is ultimately to reach these communities and we understand their realities of being disconnected from the internet, disconnected from power grids, then what is really the best way to reach them? Is it to prioritize the use of new technology when we know it's not necessarily the best fit for that community's needs? Or are there alternatives that we should be exploring if the goal is ultimately to reach these communities and provide them with the social protection and the other entitlements that they need? So I think really making that decision early on, confronting the realities of people's current situations and not rushing to implement tools before they're necessarily going to be effective for certain groups is certainly one thing. And I think having proper resources to, if we decide to use these tools, to ensure that people are not being left behind. And that's about, maybe there will need to be additional outreach. There will need to be additional data collection that is targeted at bringing people up to the same level. We can't use a one-size-fits-all approach when we know that there are inequalities that already exist. So I think being very mindful of those in the way that programs are designed is another way of ensuring that these communities aren't left behind. And I think the final thing I would say is it's important to use these tools and to find ways of, getting benefits from them. But at least in the early stages, it's important to have real alternatives for people to be able to use. There can't be a kind of a one track. I think that's what we've seen happen in Uganda, where when you open up a digital pathway and it's the only pathway and people are excluded from that pathway, then they are excluded from the entire system. So at least in early stages, it's important to have real alternatives that people can still continue to access what they need to access, and not to just kind of jump into a digital only, or as the UK famously said, digital by default system, when we know that not everyone will be able to access it easily.
Thanks, Katelyn. Richard.
So, I think mine was also to emphasize that new technologies such as machine learning could also address some of the exclusion issues associated with minority communities. So a very good example is in a number of countries, you have a national ID system, which is not having 100% coverage. And you have a social protection system that then is designed to reach the vulnerable persons who sometimes also do not have these IDs. So in a way, for example, using potentially, say, machine learning to address the duplication, which is a major concern by persons who design these particular schemes, you're able then to have a technology that is then trying to improve inclusion or address the issue of inclusion. So I think that, so it depends on I guess ultimately, it's important to have a strategy overall. And I think there are questions related to what does it cost, maybe potential visibility, and even in some context, data privacy impact assessment may need to be undertaken before these technologies, emerging technologies are implemented. Over.
Thank you very much for that addition there, Richard. We've received a question from Karensa Donnelly, and this question is, what is the best recommendation to monitor data? Who accesses it, and how can you track changes that are being made? Anyone can answer, but I wonder perhaps Peter, if you have any examples about monitoring data and monitoring access and tracking changes from HSNP that you'd like to share with us.
Thank you. I think for this particular question, unless I'm not clear with it, it more or less negates machine learning. So this goes to deterministic or rule-based methods of being able to view and manage data in terms of read writes and changes. And I think that is more, that can be easily implemented in an MIS, so in a management information system for social protection. If you would want to look into machine learning for that, I think it would be possibly implementing things like fraud detection algorithms, trying to learn or trying to teach a model to see whatever changes that are happening and trying to detect anomalies. And of course, that would need a lot of data for such a model to be trained to be able to identify such over.
Thanks, Peter. We've got another question here from Paul Crook. This one isn't directed at a specific member of the panel, but it's an interesting question. All the same, are we witnessing multilaterals taking up budget to do digital ID and leaving government behind? He notes the points made regarding lack of census and acknowledging people as citizens of a country, but are digitally known as a beneficiary for humanitarian response work. So are we witnessing multilaterals taking up budget to do digital ID and leaving governments behind, I think is the core question here. Does anyone have an answer that they want to put forward or a discussion point around that?
I'm not sure exactly what Paul means in terms of multilaterals. If he's talking, it seems specifically about humanitarian organizations or whether it's a private sector question. But I did see a couple of other questions also about this kind of competitive angle between governments and perhaps other humanitarian actors or other international organizations in gathering information and gathering data and using things like digital ID, but also things like machine learning to use predictive models and to target their programs. I don't know that governments are necessarily being left behind. I think a lot of governments are investing quite heavily now in digital ID systems. And while maybe that was true sort of 10 years ago, I think it's less true now. I think there's been a major push in virtually every country around the world to explore whether some sort of digital ID system, whether it's centralized, federated, will work for them. I think that the question about whether people are known to be beneficiaries of programs but not acknowledged as citizens of a country is a much deeper political question and isn't necessarily about the technology itself. I think that's, as I was touching upon in my presentation, I think a lot of these systems are designed in such a way that they reflect some of these political choices. And it's not necessarily that these people cannot be identified as citizens, is that they are woefully being excluded as citizens. So I think that goes down to really the design choices that are behind each of these systems and the different motivations that will inflect, not just the divide between government and humanitarian organizations, but also different branches of government will obviously have different motivations. So a system that's designed for a hunger safety net program will obviously be designed in a different way than something that's coming from something like a Ministry of Interior or a security apparatus of some sort. So I think that there are a lot of these friction points between different identification systems, and it does add another challenge to using data from multiple sources, because they will all be kind of inflected with the design choices and the motivations of the different actors who've collected the information, inflected by the biases and the preferences of those organizations. And it is something I think that needs to be addressed when pulling from different databases that have been collected by different actors.
Thanks very much, Katelyn. We've still got plenty of questions to keep us going here. One of the questions is directed at Richard and at Boniface. And it asks, how can we harness the power of machine learning to keep social registry data up to date and useful for programs? I know we've covered quite a bit of this, but if you have any additional points that you'd like to add, yeah, there's a space here now to do that. That's questions from Asan Jalo.
Yeah, so I think, before I answer that, and then maybe Boniface can weigh in, I wanted to speak also to the previous point around investments that are made by governments to technologies, including emerging ones, machine learning and others, vis-a-vis maybe benefits going to social protection beneficiaries. So there's a bit of a budget and political economic issue there. And I think the previous UN rapporteur, I coined a term. It was called digital, I'm forgetting but basically the meaning is, it meant you create efficiency by employing newer technologies, but then you take the budgets that could then be given to vulnerable persons or beneficiaries elsewhere. Digital austerity, that's the term I was looking for. So, so that's the essence. So I think I guess social protection actors can make a case. You can make a case for efficiencies, you can make a case for employment of technologies, of course with appropriate safeguards and mitigation of risks. However, any savings that we accrued from that can then be reinvested by giving more benefits or even scaling up the programs. So all these are feasibility questions that need to be considered. In terms of the registries updates, I think it really depends on the data available within the environment. I think in terms of social registry designs, the biggest issue is updating the data, and the biggest cost is updating the data. So most countries that set up registries, social registries, tend to, even though they have a shorter cycles by design of updating the registries, they end up having updating these registries after 10 years, which makes the data outdated. So I think I've been debating with Peter whether with existing information systems and data, say supervised learning, whether the machine learning systems can be established so that there is effectively harvesting of the data. But again, you have to have appropriate data protection protocols in place to be able to do that. It's something that is very challenging, for example, to do it, say, in Europe because of the GDPR regulatory framework. So you have to do that. What I know is even outside the machine learning discussion, most designers of social registries are now also looking into administrative data sources as a way of, as a mechanism of updating the data and looking into options of on-demand updates to avoid a very expensive census that has to happen potentially every 10 years. I don't know whether, maybe Boniface, you can weigh in, and then maybe Peter, if you have anything else in terms of actual design of the model, whether it could actually work, a machine learning model would also work for getting the data from multiple administrative data of government to then update a social registry.
Yeah, I think I have two or so more points. I think as Peter showcased one of the models that he has, of the automation and chatbots and so on and so forth, we can use machine learning in automating the update process, which is the expensive bit of the social registries. So such that individuals can update their own information, and we've said that you can have this kind of hosting or deployment of machine learning through mobile apps and other functionalities. You can have bots like Telegram and so on and so forth, where beneficiaries can do that. You can also use the predictive modeling, where the system can be checking the beneficiaries in these registries who are at the risk of falling out, or they have changed their composition, change of family composition. This data can also now, with other mechanisms and other ways, we can have modeling and integration with other systems, where now, like we have two different systems. With machine learning, can update the data. Also, maybe we have a social registry and we have the national register or census registry. The two can be combined through, and then the system can learn and update the beneficiary data. And yeah, I think those are the 2-3 points I could have read on that. Maybe over to Peter.
Thank you very much. I think you captured almost what I wanted to speak to. But taking consideration, for example, we are used to generating questionnaires to capture data. Something like natural language processing can interact with a beneficiary through natural language, and a beneficiary can be able to update. It can, for example, trigger a chat session with a beneficiary and mine data and update, for example, a database using natural language processing. And that negates the element of filling forms and going through a lot of processes in terms of updating of data. You can also look at what Boniface spoke to. You can cluster data in terms of, for example, if you have historical data updates, you can be able to use those historical data updates to cluster new data to give you probabilities of households that require data updating or households that are highly likely to update their data. A quick example, for example, if you were to go back to role-based, if you were to select a query from our database of households that would potentially be updating their data would look, for example, for young families with young children, would be looking for such, like we can be already to know that if these are school-going children, there is possibility of data updating in terms of their education or their health status, or even new membership and so forth. But these are things that we can experiment. However, for us in HSNP, we haven't attempted such. Over.
Thank you very much, Peter, and to all of the team today. We'll round it up here and make that the very last question. But I want to say thank you very much to everyone who joined, all the participants on the line here. I can see from the chat we've got people from all around the world joining us today. So thanks for joining. And thank you very much to Richard, to Peter, to Katelyn and Boniface for their wonderful presentations and the great discussion today. And finally, thanks to socialprotection.org for their support on the webinar. Hopefully we'll see you all again soon.